4. So the first one we want to identify is the axis of symmetry. Now, before you guys get into any of this, we need to remember the vertex form of a quadratic. Y equals a times x minus h squared plus k. Right? So we know standard form, y equals ax squared plus bx plus c. And then we have our vertex form, which is right there. So what's nice about the vertex form is we can easily identify the vertex, as well as the axis of symmetry. The axis of symmetry, ladies and gentlemen, is just x equals h. Right? Well, remember, it's x minus h. Right? X minus h. So therefore, x equals 1/2. Right? So therefore, my axis of symmetry is at 1/2. Now remember, the axis of symmetry is a line. It's not a point like the vertex. So it's a line. X equals 1/2 creates a vertical line at the x value of 1/2. The vertex is the point, either the maximum or the minimum, right? It's where the graph kind of changes, right? So the vertex is simply h comma k in vertex form. So well, we already know what h is, which is 1/2. And k is going to be this number right here, which is -5. See how easy that was? Yes?
Didn't you reverse when you were taking it out? Like, do you leave the negative?
No, that's what I'm saying. Like, it's x minus 1/2. Think about it like this. It's x minus h. X minus h. Do you see how h is equal to 1/2? See how that works? Okay. However, if it was like if it was x minus 1/2, then that would also look like x plus 1/2, and that's why h would be a -1/2. See, if it was x minus a -1/2, that's the same thing as x plus 1/2, right? Minus a negative, the same thing as plus, right? That's why h would equal -1/2. So yes, that's why a lot of times we think of those as the opposite. All right. The next thing I asked you guys was the vertical transformation, horizontal transformation. So the vertical transformation is going to be how is the graph moving, where is it moving, and so forth. Well, you want to get, Michaela will give you a sheet of paper. She put them over there for you. So if you guys look at this, if you guys remember the graph originally, if you guys remember a quadratic, originally the vertex was at 0, 0. Right? The vertex was really at 0, 0, and the graph originally opened up. However, if the vertex is now at positive 1/2, -5, right? The graph has now been shifted down 5, right? It's been moved over 1/2 and then down 5. You guys agree with me? So the vertical transformation is down 5 units. Right? Because now the vertex is at -5, so now I'm shifting the graph down 5 units. The horizontal transformation, which I called the HT, that is going to be right 1/2 units. Right? Since h is 1/2, now my x vertex is not 0, 0 anymore. It's now 1/2. So the graph has been moved, shifted over to the right 1/2. The next thing was the C/S, which is compression or stretching. Now, if you remember, there was some notes in here. A was very important because A told us if it was positive, if the graph opened up, right? Or when it was positive, the graph opened up. When it was negative, that said there was a reflection about the x-axis, and therefore the graph now opened down. So you can see here, we do have a reflection, right? The graph is now going to open down. Yes? However, that doesn't tell us anything about the stretching or compression. Stretching or compression is in the absolute value of A. When the absolute value of A was greater than 1, when the absolute value of A was greater than 1, what that did was that horizontally compressed the graph. So horizontal compression. And when the absolute value of A was less than 1, that was a horizontal stretch. Okay, so what that would do is that would stretch the graph. So is the absolute value of -3 is 3. Is that greater than 1? This absolute value of -3 is 3. Is 3 greater than 1? Yes. So what that does is that compresses the graph horizontally. So therefore, we could say that it's a horizontal compression of a factor 3. Okay, so it's compressing the graph. It's making it skinnier a lot of times, as we like to think about. And then the last one is domain and range. Dun, 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 dun. Do you? Bet you don't. What's the domain? It's all real numbers, right? It's always going to be all real numbers. When you guys look at this graph for all quadratics, I don't care where it's shifted, where it's reflected, how it's compressed or stretched. It doesn't matter. The graph, the end behavior of the graph, which we now know, is just going to keep on going up and keep on getting wider and wider, right? Even if it's a really skinny graph, it's going to keep on going up, but it's going to keep on going wider and wider. So therefore, it's all real numbers. But in interval notation, we're going to write that as negative infinity to infinity. All right? Now, to understand the range, it is very important to kind of understand what this graph would look like. So if here's your parent graph, the range of this one is the y values. Remember, the domain is the x values. This graph goes infinitely to the left and to infinity to the right. However, the range of this graph, the lowest the graph goes is 0, and the highest the graph goes would be infinity. Does everybody see the range of that? But if we now change the vertex to be at 1/2 -5, we do a reflection of -3. So therefore, now the graph is facing down. And it doesn't really matter the compression, but let's just pretend that looks like the graph or whatever. Compression's really not going to affect it. Compression doesn't affect the domain or range at all. However, if we look at the range, how low does this graph? Yes?
Would it be like all real numbers and then comma, like -5?
Well, close. We're not going to go to all real numbers. We're just going to say, we basically want to ask ourselves or say out loud, how low is this graph going to go? It's not going to be all real numbers, but how low does it go to? Negative infinity. And then how high does it go to? -5, right? And notice how -5 is a part of your vertex, right? Because remember, when they ask you for the maximum or the minimum, your vertex is always either going to be the maximum or it's going to be the minimum of the graph. So my range is from negative infinity to -5. However, is negative infinity an actual coordinate point on the graph? No. So therefore, that's why we use parentheses. Is -5 an actual coordinate on this graph? Yes. So that's why we use a bracket. The bracket says it's included in the graph. The parenthesis says it's not included in the graph. Is that enough information to get you guys started for